As a database administrator, one of the most important tasks that you'll be responsible for is safeguarding the company's data. Corporate data is one of the most valuable assets of any organization. You'll need to protect it from hardware failure, from corruption in the system due to power failures or any other type of event that could corrupt the data files. Theft. You'll need to be sure that your backups as well as the online data are secure against unintended users. These are some of the things you want to plan for. These are some of the things you want to prepare for. Hi, I'm Mel Haynes, and in this video we'll be looking at how do you back up your data, how do you ensure that those backups are secure, and then how do you recover that data in the event of a data loss. So in this video, I'm going to cover basically 6 things. The first thing I'm going to get into is what are we backing up when we talk about backing up an SQL Server 2008 database. We'll talk about the files, we'll talk about some of the other system databases, and then we'll focus on backing up our production database, our Veronica's database. Second, I'm going to run you through a basic backup and restore. In this video, I'm assuming you have some familiarity with backups, since this is the Advanced SQL Server course, but I don't want to completely gloss over that, so we're going to just run through a basic backup and then restore the data. After that, we'll get into database recovery models and then backup types, and I'll give you a little heads up on that. Database recovery models are about what's available to be backed up. Backup types are when you actually go in and back up the data. And we'll get into that in more detail, but recovery models are about what is SQL Server saving that we can back up versus what are we actually backing up. Fifth on the list, transparent data encryption. We can encrypt our file system, right? Okay, now it's encrypted. How do I restore it if I need to, if something goes wrong, right? So how do I restore an encrypted database? We'll run you through that process so you're familiar with that. And then last but not least, working with database snapshots. When we talk about backing up SQL Server, we're talking about backing up the physical files that make up the data, obviously. Database backups traditionally have backed up 2 types of files: your MDF, main database file, and your NDF. You always have one MDF and you have 0 or more NDFs depending on how you design your database. A backup backs up at least those 2. The LDF is your log information. That gets backed up when you back up your transaction log. So you want to back up your database and your transaction log to get all of your data. What else is included? File stream data. SQL Server 2008 allows you to store pictures or sound bites or other types of non-textual information or large objects, right? In your data hierarchy, not necessarily in the physical database files, and then interact with the data using T-SQL. That is also backed up, which is kind of cool. So when you say back up the database, you're getting your MDF data, you're getting your NDF data, and you're getting your file stream information. Way cool. All that's included for free. What else do you get? Your full text catalogs. They're in the database and are also backed up when you back up the database. So no additional thought is required to make sure you're backing up your full text catalogs. That wasn't the case in SQL Server 2005. So that's an improvement for SQL Server 2008. One other thing I want to mention about backups, we've been focusing on backing up our production database, Veronica's, and all the pictures of our flowers in our database and things of that nature. But SQL Server 2008 manages itself and all the data that it needs to track what's what in the environment by using databases as well, your system databases. Let's look at our system databases real quick. All right, I'm over on my server and I'm going to expand my databases folder and just kind of walk you through this. My system databases folder contains 4 of the common system databases. There's another one, distribution, which you don't see here yet because I don't have replication installed, but replication would add a 5th system database. But the master database is going to be used to house all the server-wide database configuration options. Anytime you change any of those, anytime you add or delete or modify a database, SQL Server knows what databases are available. That's how it knows about Veronica's, because of information in the master database. Anytime you create a new database, you want to back up your master database. File groups. If you're adding or deleting file groups or files, same things. Logins, security configuration, all that is saved in the master. You want to back up your master. Next, looking at the model database. The model database is basically a template for creating new databases. Let's say your starting point for the new databases you're creating in your environment is pretty elaborate. You have certain basic corporate things that need to be in there, certain rules, regulations, tables. You can put that in your model, and whenever you create a new database, you'll automatically have that stuff. Once again, if you like your work and you want to keep it, back it up. You want to back up your model database as soon as you make those kind of changes in the model. MSDB, anything that happens automatically in SQL Server. So if you set up your backups to happen at certain intervals, or you've set up policy-based management, that kind of stuff is going to be saved in your MSDB. So anytime you do anything with SQL Server agent, any type of jobs that run automatically, or anything associated with policy-based management, that stuff is saved here. TempDB, don't bother. It's just a scratch pad that SQL Server uses when it's building queries and result sets. So you never want to waste time backing up TempDB, just FYI. But those databases, along with the distribution database, are your system databases that you'll want to pay attention to make sure they are also being backed up regularly. So let's jump into performing a basic backup of an SQL Server database, our Veronica's, and then restoring that database. So let's start with a basic backup. Go to my Start menu, SQL Server Management Studio. Go ahead and log in as administrator in my case. My Object Explorer fills in. If I expand to Veronica's and right-click, go to Tasks, about the fourth down, and scoot over to Backup, about a third down on that menu. Click there, and I get my Backup database menu. So let's talk about this screen. First of all, I have two options on the left, General and Options. Right. First one gives me a place where I can select the database. Since I right-clicked on Veronica's, it took me directly to Veronica's, but I could pick that or a different database here on the drop-down. Recovery model, that's a separate entity. It's really talking more about what's available to be backed up when you're looking at recovery models. Backup type, when that says full, we're saying backup everything. Next on the list is differential backup, right? Give me only what's changed since the last full backup. Then last on the list is transaction log. That's my LDF file. Remember, your primary database files are going to be your MDFs and your NDFs, as well as your file stream information, right? All that's included up here. Transaction log backups are a separate decision. For now, I'm going with a basic full backup. I could tell it copy only. Not going to touch that just yet. Backup component, I can say backup the database versus specific files and file groups. So in my case, my Veronica's database only has one file group, and that's the primary file group, and everything is on that file group. But primarily for backup purposes, you may decide to break up your data across multiple file groups, put them on separate drives. That allows you to pick certain subsets of your data, say the part that's most volatile, and back that up more often. Also for performance, you might find that by separating them out across different drives, you can get better performance as well. But I don't have to deal with that in this case. Everything's in one file group, so I'll cancel out of this. Backup set. SQL Server gives me a default name based on the name of the database and the name of the backup type. So I'm in Veronica's and I'm doing a full database backup. I can give it an additional description if I like, but that's pretty explicit for me for now. Backup set will expire after. Putting in a 0 says it does not expire, or I can have it expire on a specific date. And then the destination for the backup. I don't have a tape drive, so mine's disabled, but if I did, I'd have that as an option as well. It's defaulting to disk, and it's defaulting to a default location where SQL Server was installed. Program files, Microsoft SQL Server, SQL, MS SQL 10, yada yada yada. You can see the rest of that list. Right down to a backup folder where it's putting a file that has the same name as my backup again, veronicas.back. If I wanted to, I could add other files. I can remove files. I'll go with the default for that. Go to Options. Back up to the existing media set. I can append to the existing backup set. This is my very first backup. Here, let's prove that. Going back to Veronica's, right-click and going to Properties. Last database backup, none. Last database log backup, none. So I haven't backed this up yet. I'm being a bad SQL Server DBA, right? So for the first time around, it doesn't matter if you pick append or not. So let's go back. Task, backup, Options. So I could append, could overwrite, double check the media set name and backup set expiration before I append. I could back up to a new media set and erase all existing data sets. Another option. SQL Server can do a verify during the backup process. It can perform a checksum before writing. And if there's an error, by default it will stop, or you could have it continue if you know there's certain problems that will arise but you want it to continue anyway. You can check this checkbox here. Since I'm not doing a transaction log backup, all the transaction log options are disabled. And the same thing with tape drive. I don't have one right now, so all that's disabled. I don't need this just yet, so I'll take that off again. So going back to general, I'm all set. One other thing that's kind of cool. If you're like me and you don't like typing script unless you have to, or if you do, you like to get as much of it pre-done as possible, there is a tool here. Script action to new query window. I could actually have it create a script. Here, let's do that. For the backup, including all the options that I just picked. So there you can see all my options, right? And I could change this here. I could run this in lieu of running the wizard. I'll go ahead and run the wizard. Click OK. That way I get to see a nice little graphic running here saying what percentage complete I am. Backup of database completed successfully. So I'm good to go. Click OK. If I right click on Veronica's again, go back to Properties, should see an update for when my database was last backed up. Now notice my log file still has a big fat none or 0 there. So here, let's go back and do the log file. Tasks, backup. Backup type this time will be transaction log. Go to Options. It's going to append. So this time I do have something to append to. Notice my transaction log information is now available. I can say truncate the transaction log when I'm done, right? All those transactions waiting in the log prior to the backup gets cut off. So it's part of the backup now. And then back up the tail of the log and leave the database in the restoring state. That's something we will do when we are restoring the database from a backup. One of the first things you do before you restore a backup is you first, if at all possible, back up the tail of the log, as it's called. You want that last portion of your transaction log, any transactions that have occurred just prior to you wanting to restore, because you want to put that stuff back onto the database, right? So I'll click OK here, and the backup of my database completed successfully. If I go out to my C drive, to that location where I told it to put this, C program files, Microsoft SQL Server, backup folder, and there's my database backup by veronicas.back. One thing to note, it's on the same disk drive as my database, which means that's not where you ultimately want to keep it, probably not even put it there, but for what I'm doing for now, that's fine. Now, you typically want to even have a copy off-site, right? What if the entire server room goes up in flames? What if the box itself is stolen, right? You do want to have copies that are off-site. Now, for some of you, you're kind of cringing at the thought of having copies of your database somewhere other than where you can easily get to them and know that they're secure. What if it's stolen somewhere else? Well, what if it's stolen locally, right? You really have the same problem. You want to solve that problem typically by encrypting the data. We'll talk about transparent data encryption and how it plays into backups separately. But there's the file. Now, life is grand. You've got your backups. Your rear end is protected in case of loss, right? And then the unthinkable happens. Computer goes kaplooey. Hard disk crashes, or that fire happens in your server room, whatever it is. You need to get this thing back up and running. How do you do it? A simple restore. But the first thing I want to do, here, let's make this a little more realistic. If you've really trashed your server beyond repair, you won't have the database there at all. So I'm going to go ahead and delete the Veronica's database. Let close any existing connections so I can blow it away. So I don't even have a database anymore. It's totally gone, right? Now if I run my restore, which I have a file out here, I'm going to use that. Open file. Let's see, move up a level, back up in restore folder, and I have a restore routine. All it does is I use the master to restore the database Veronica's from disk. Let's break the line so we can actually see a little bit more of that. There's a full path to the file, and hit execute. Gives me a quick rundown, 100% processed. All pages are back. Log files are back. Restore successful, way cool. And if I refresh over here, there's my Veronica's database. Everything's back, life is good. We survived another day. So let's jump into recovery models. Now, in this course, I'm not going to spend quite as much time focusing on some of the intro level stuff of backups and recovery, because recovery models are really SQL Server Backup 101, but I do want to at least recap a little bit of it. If you need more information, I can suggest a couple of sources. First of all, Microsoft's website, there's an overview of recovery models on Books Online at MSDN. And then the other thing, of course, is my intro to SQL Server administration. Actually, it's called SQL Server 2008 Administration Training, where I get into this in a little more detail. But I do want to recap the 3 recovery models, starting with simple, which is exactly that. If you're working with a simple recovery model, one of the primary things to note is you have no log files. So what does that mean? You cannot recover to a specific point in time. You can only recover to the point your database, or the state your database was in the last time you created a backup. So if you're doing a backup once a day or once a week, whatever that database looked like at the time you finished that backup, that's the point, that's the state it's going to be in when you restore that backup. Now on the upside with simple, there's no management of log files. One thing you have to watch out for with all the other models is log files are growing every time a transaction is made. Log files could potentially cause you to run out of disk space. If that happens, SQL Server doesn't take very kindly to that. You will have major problems, possibly a server crash. So you have to manage the process. If you have a database that for some reason or another you don't need to have point-in-time recovery, you can go with simple. That way you don't have the overhead of managing log files. The primary recovery model you're going to see in SQL Server is the full recovery model. This one does keep log files, so it requires you to back up your log files to get rid of them periodically. The upside is there's no work loss due to a lost or damaged data file. So if your database is corrupted or goes up in flames or whatever, somebody makes a catastrophic data change and just corrupts all kinds of numbers and values in the data, right? You can restore the database to the point just before that action happened, or to just before the point that catastrophe happened or the fire or whatever. You can go right back. So your work loss exposure with the full recovery model ideally should be none. Now there are some steps you need to take in order to restore your database when you're using the full recovery model, and if you don't follow those correctly, you could still end up with some data loss. For example, you should back up your database creating a full backup, and then possibly create differential backups. We'll talk about this later on when we get into the backup types, and then create log file backups. So you'll have 3 different things, possibly 2. You don't have to have the differential. That's a speed improvement type of mechanism. But at a minimum, you have to have 1 full backup and log file backups, possibly a differential, right? But then the key thing you have to add into that is before you restore a database, using the full recovery model, you want to make one final backup of what's known as the tail of the log file, the last little bit of stuff that's in your log file that has not yet been incorporated into your regular backup schedule. Okay, so provided you do that last little step, back up that log file and then do a restore, you shouldn't have any data loss. And then as far as recovery to a point in time, this is the one that gives you, well, actually two of them do, but this one gives you the ability to recover to a specific point in time. Right? Those are your primary two recovery models you're going to see implemented in an SQL Server environment, either the simple or the full. And once again, this is only the recovery model. These aren't the backup types yet. And I haven't said my favorite phrase yet, but it helps to clarify this, and it helped me a lot too when I kind of figured that out. Recovery models are determining what's available to be backed up. This is not backing up the data yet. This is only determining what's available to be backed up. Later on, we'll get into 4 different types of backups you can perform. But for now, I'm saying simple allows me to run the database and not have to deal with log files because they're not there, so you can't back them up. The full recovery model creates log files, and I can back those up. You don't have to back them up, but really, what would be the point of creating them if you didn't back them up, right? So that's the difference between those two. Your third recovery model is your bulk logged. Your bulk logged recovery model is really an adjunct to the full recovery model that gives you a little better performance when you're dealing with bulk copy operations. What do I mean by that? Let's say you get a daily or weekly update of data from some third-party source, another remote office or a third-party vendor you buy data from, and it increases the total amount of information in your database by 5% or 20%. So it's a relatively large amount of new information coming in all at once. You don't necessarily need to be able to recover your database to a specific point in time in the midst of that bulk copy operation. You could look at that bulk copy as one big new chunk of data just kind of stuck in your database, right? That's what bulk logged allows you to do. The individual transactions that are part of a bulk copy operation and a few other different types of bulk operations, the individual transactions are not individually identifiable within a bulk logged transaction, so you can't recover to a specific point in time anymore. Now, as far as work loss, still no work is lost, provided you do your log backups immediately after a bulk logged operation. So let's say you're in the bulk logged recovery model and you do some type of a bulk logged operation. Right after that operation, you want to do a log file backup. Provided you do that, you're still in the situation where you don't lose any data. The only thing you've lost is the ability to restore to a specific point in time. Now, when you're dealing with full and bulk logged recovery, you typically don't run in bulk logged. You may switch to your bulk log recovery model briefly in order to do a bulk transaction, such as a bulk copy. After that bulk copy is done, like I said, that daily update or weekly update, you want to switch back to your full recovery model. But those are your 3 recovery models. So looking at backup types. Before I look at the 3 main types which are listed there, full, differential, and transaction log, I want to focus on the bottom half of the screen first, where it says backup component, database versus files and file groups. Your SQL Server database is made up of various files, obviously. You can, if you design it wisely, separate portions of the database that need to be backed up more often from portions that don't need to be backed up as often. That can become very helpful. It's very important to do that when you get into larger databases. Databases that can't be backed up in a reasonable amount of time. If it gets to the point where your database takes more than 24 hours to back up, more than a weekend to back up, you've got a problem. You really don't have a window to back up your entire database. But chances are it's not the entire database that's been changed, and it's not the entire database that needs to be backed up that often. So you want to break the database up into files and then group those files into file groups, and then you can select what portion of the database to back up at any particular point in time. Now, so once you've answered the database versus files and file group question, then you can move into selecting either a full backup, differential backup, or transaction log backup. A full database backup backs up the entire database, including part of the transaction log. So your full database backup can actually be used to recover your database, which makes sense. Now, the moment you process any additional transactions after that full database backup, now you'll have to have a transaction log backup if you want to be able to restore the database up to the current point in time where the error occurred or the crash happened or whatever it is that's causing you to need to restore. Full database backups are going to be the most commonly used backup method. If you're using any of the other methods, you'll still need a full database backup as sort of a benchmark. So if you're using differential or anything else, you'll want to have a full database backup as a starting point. And then from that point on, you can go ahead to back up only certain files or file groups or differential backups. But you'll want to have a full backup to start with. Next, we have our differential backup. The differential backup backs up everything that's changed since your last full backup. You don't have to use differential backups. If all you're doing is full backups and transaction log backups, you have everything you need to restore your database at any point in time. The problem is the restore time will take much longer, or could take much longer depending on the amount of transactions, if all you have is full and transaction log backups. Differential backups allow you to speed the restore process up, because now you, in the event of a system failure, you restore the full backup first. Next, you simply restore the differential backup, which is much faster, will get you to that point in time much faster than if all you had was a log file. And then you can apply any transaction logs last. So a common scenario would be back up the entire database once a week, do differential backups once per day, do transaction log backups periodically throughout the day. Now, in the event of a system failure, I have my full backup I can restore first, then my differential backup. Let's say the system failed on Thursday. I have differential backups for every day of the week, Monday, Tuesday, Wednesday, and Thursday. However, I don't need the differential backups for Monday, Tuesday, Wednesday. I don't need to restore those. All I need to do to restore my database that crashed on Thursday, and assuming I took my differential first thing Thursday morning, right? I can restore the full database backup. I can restore the Thursday morning differential backup, and then transaction logs up to the point where the failure or the problem occurred. It's much faster than if I had to restore all those transaction logs for the entire week. Next, we have our log backup. Log backup backs up your transaction log. You want to back up your transaction log. If you're working in an SQL Server and you're doing anything with backups, I hope you're already doing that. So this should be just kind of reiterating the obvious, reiterating the basic. You're going to be backing up your transaction logs. When you go to restore, I'll just kind of jump ahead a little bit to the restore process. When you go to restore, the first thing you do before you restore a database is to back up the tail of the transaction log. So there's one other place where you'll do a backup of the transaction log, and that is as part of your restore. But we'll see that in more detail when we actually get into restoring the database. And then another option on this screen is the copy only option. Notice the checkbox there. Copy only will not interfere with the backup cycle. So for example, if I'm doing regular backups, I have a full backup once a week, I have differential backups once a day, I have transaction logs throughout the day. SQL Server is keeping track of what's been done most recently, so it knows what should be in a differential backup. Every time I take a differential backup, SQL Server knows what's in that differential versus any others that come later. The copy only doesn't interfere with any of SQL Server's markers regarding what has and what has not been backed up. So it's a great way to go in and just make a copy of the database in its current state and not interfere with any of your regular, hopefully automated, backup procedures. So what we want to look at now is what does it take to back up and then restore a database that's been encrypted with transparent data encryption. TDE works great for protecting your data. Turn it on, it runs in the background, you never have to think about it with regards to your file system, but when you need to restore, perhaps to a completely different server, what are the steps? Let's look at that now. So let's start out by making sure we all have an encrypted copy of Veronica's. Bringing up my Management Studio. Go ahead and connect. Now, to make sure my database is encrypted, go to File, Open File. I'm going to go up a level to my encryption folder. Now, for those of you who did the encryption video already, we get into the transparent data encryption more over there, but for those of you who jump directly to this one, I'm going to bring this up, the TDE script. In case you missed that, I grabbed the enable TDE DB script, and it should look, and maximize this, something like this. Use master, create master key encryption by password. Don't really need to use masters unless you're running this in small segments. Create certificate, Veronica's server cert. And as soon as I create that certificate, as I say in my encryption video, you back it up. So you want to have that backed up, because without that backup, you, of course, as I said in the other video, you cannot unencrypt this database backup. Okay, so you could restore the data, you won't even be able to restore it, but even if you could, you can't read it. So you want to back it up. You create the database encryption key next, and then you turn on encryption. And then I simply just checked on the status of my encryption. So here, I'll just run this whole thing. And the only output we should see is the final encryption state, which simply says 2, which is what? For those of you who've seen that video, it simply means that it's in the process of being encrypted. It's selecting the encryption state for that database. If I run that again, though, it only takes a matter of seconds based on the size of our database to complete the process, and that is what a 3 stands for. So my Veronica's database is all encrypted. Let's back it up. Right-click, go to Tasks, Backup. Going with a full backup. That name is totally fine. The default location is totally fine for what I'm doing right now. Of course, in the real world, you're not going to back up your database to your hard drive, right? Options, overwrite all existing backup sets. Why do I want to do that? Well, I'm encrypting it now. I don't want any unencrypted copies of the backup laying around out there. I want everything encrypted. Made it to 100% successfully. Way cool. Click OK. And I'm going to go ahead and back up my transaction file too, just because typically you'd have that out there. So back up again. This time change this to transaction log as opposed to a full backup. We're doing just the transaction log. Same default location, not changing a thing there. All right, C program files, Microsoft, yada, 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 all the way down to my Veronica's.back. If I want to add a different location somewhere on some other shared network location, just go here. But C drive is good for now. For options, I don't need to change a thing. Overwrite all existing backup sets. I definitely don't want to do that this time around. I want to append to my full backup. So click OK again, and this will go twice as fast because I have no transactions out there. Click OK. So I've backed up my database. I encrypted it, then I backed it up. So I'm good to go. Now when disaster strikes, right click, here's my disaster happening right now. See, watch this. Delete database. Some unscrupulous person came along and deleted our Veronica's database. And as soon as that's done, they were smart enough to delete the certificates we need to restore it. So I'll just mosey down into that folder as well. Certificates, there's my Veronica server cert. Same one I created right here. I refer to it right there. I created it right up here, right? That's that server cert I created. Blow that away as well. Or let's say, we just had a legitimate server failure. We have to reinstall or restore the entire thing on another instance of SQL Server. That server cert won't be there. So I'll still need to somehow or another get that back in place, right? But I've been a good database administrator. My database is backed up. I backed up my server cert to a file location somewhere, right? It's currently just on my C drive, but somewhere, and I know where that is. Let's restore my database. Here, I'm going to open a script again. File, open file. And I'm going to go to my backup and restore folder. By the way, there are my two keys that I backed up. And I have a restore with transparent data encryption. Restore with TDE. Double click that. And we did some restore in other places where all we needed was this. And here, let's play around with this. Let's do it the wrong way first. Make a little change. Let's say all I tried to do was restore the database. I don't have the certificate stuff. I'm going to just highlight and run only that portion. Hit execute. Cannot find server certificate with thumbprint, and there's that long encrypted value. Restore database is terminated because they didn't have my certificate. Now, let's get rid of that. This statement here, create certificate, it looks just like the statement I used, at least starting off, to create my certificate, right? Create certificate, gave it a name. That part's the same. What's different is I'm now creating it from a file, an existing file, and I give it the same information I needed before when I did the backup. Private key, file, decryption, by password. I did basically the opposite over here. Private key, there's that file again, encryption by password, right? So I'll still need that password. But with all of that in place, we can do this in segments one at a time, or we can do it all at once. Let's just do it all at once. Click up here at the top, hit execute. Processed 1,160 pages for database Veronicas. And if I refresh my certificates, I should see my Veronica cert is back in place. My Veronica's database, if I refresh here, is also back in place. I can query it again. Here, let's look at some data. Right click on my customer table, select the top 1,000 rows or whatever is easy. There's my data, back from disaster. And that was with an encrypted database. But once again, the key thing to note is, and let's get rid of this extra stuff we don't need, is I had to have not just my backup file, right, wherever that was located, and all mine's on my C drive for now. I also needed to have my private key file and my certificate file. Storing all those, oh, well, and then of course, one more important thing. I needed my password, need that password. So the moral of the story is make sure you have all of that and make sure you have them all in separate places. Please don't make the mistake of backing up your file somewhere and keeping everything else in the same location. You do want to try and keep those separate if possible. But there you go. We've backed up and restored our Veronica database, and this time as an encrypted database. Way cool. So we've looked at creating backups of our SQL Server database. But what if I just need a picture in time of the database and I don't want to interfere with the backup process? So for example, if I sneak in, I've got automated backups happening at regular intervals. If I sneak in and create an extra backup, I've changed how things are flowing for SQL Server. For example, if I go in and create an additional differential backup, that's going to change what's going on with the backup cycle. How can I jump in and create a copy of or a picture of the database without interfering with the backup process? SQL Server 2008 Snapshots allows me to do that. So here, let's jump over to the server and actually look at taking a snapshot. So here, let's go ahead and bring up Management Studio and type in just a little bit of code that'll allow us to create a snapshot. Pretty easy stuff, but very, very handy if you want to just take a quick picture of your data for archiving. While I'm waiting for this to come up, just remember, this is not a substitute for backups. It's just a way to get a picture of your data as an additional measure for archiving and an additional measure of security. But here, go ahead and log in. Bring up a new query window. I'm going to tell it to use Veronica's. And then use the create database statement to do this, because it's just an option on create database. Give my snapshot a name, and I'll just call it Veronica's _SS for snapshot. Create it on, open a paren, use the logical name, which is basically the database name, which is simply Veronica's. tell it where to put the snapshot. You could pick the location of choice. I'm going to stick mine in my course files folder since I know that folder already exists. Make sure I put all of that there. File name equals course files / Veronica's. Make up a name that makes me happy. And Microsoft, in most of their documentation, is putting an SS extension on the end of the file, and that's completely arbitrary. You can put any extension you want, but you probably want to put something, have some standard that you use consistently to keep track of your snapshots, assuming you're doing this for on more than one occasion. And here's the key part. I'm using the create database statement. I have to specifically say as snapshot so that it knows to make this a snapshot of, and then I give it the database that I'm making the snapshot of, which is Veronica's. Give it a go. Hit execute. Commands completed successfully. Let's see what I got. My Veronica's database is still in place, but my database snapshots folder, expand that, and there's my Veronica's _SS. Expand that, and I can see all the tables. Once again, this is all read-only now, but I can query it just like before, so I can select the top 1,000 rows using standard SQL. But if I were to try and do an update, I'd get an error because it is read-only. All right, so there I have that. Location is right here where we said we wanted to put it. Here, let's minimize that. So if I go to C course files, I should be able to see that file there. Here, let's do that. And there's my Veronica snapshot. I could back that up somewhere else, and I'm good to go. So that's creating a snapshot. So what did we cover in this video? SQL Server backups and restores. That was the gist of it. We did kind of a high level, what does a backup look like? What does a restore look like? Before getting into some other details, we talked about the system files. We talked about the system databases. What are the components you need to back up, right? We looked at full text catalogs as well as file stream data, and I mentioned how all of that, it's in there, right? You do a backup, you get your file stream information for free, you get your full text catalog information for free, no extra work required. I talked about your database recovery models. Kind of reviewed that topic, mentioned that database recovery models are all about what's being saved so that you can later back it up. And the biggie was log files. You have a choice of creating or not creating transaction logs. SQL Server 2008 backup types. Talked about that, such as a full backup, differential backup, log backups, and what are some of the differences. When you're working with transparent data encryption, what's changed? The biggie, make sure you have a backup of your certificate. The data is encrypted in the production database and in any backups you create. So if you need to restore that backup to another server or rebuild the server, you'll need to have not just the database backups, you'll also need to have that certificate. So you'll want to back that up. That's not part of the normal backup process through the graphical user interface. We showed you how to do that using T-SQL. Make sure you back up those files and then put those in a safe place as well, preferably separate from the database backup files. And then we looked at snapshots and showed you how you could jump in and take a quick snapshot, right, of your data that you could possibly use for reporting or any other types of analysis that you can do with offline data. So with that, we come to the end of our video on SQL Server 2008 backups and restore. Thank you for watching, and I look forward to seeing you in the next video.